Welcome, friends. Today we are going to learn the next chapter, that is the Earth system. Hi, myself Ram Kolkar, Assistant Professor, Naurochiwadia College, Pune. The study points in this chapter are: first point is interior of the Earth based on seismic evidences, theory of isostasy, Wegener's continental drift theory, crustal movements, and folding and faulting. So in this video, we are going to learn about interior of the Earth based on seismic evidences. Interior of the Earth is not the composed with homogeneous material. It is heterogeneous material. Interior of the Earth has concentric layers having different properties. The deepest hole drilled in the Earth is only about 12 km at Akola Peninsula in Russia. Denser material are settled down at the core of the Earth, while low density material forms crust of the Earth. Increasing temperature towards the core of the Earth, and that is the rate of 1 degree Celsius per 32 meter. The most authentic evidence about composition and structure of the Earth is seismic waves or earthquake waves. There are three types of seismic waves: P waves, S waves, and surface waves. The P waves, these are also known as primary waves or longitudinal waves. These are high frequency waves or short wavelength waves. These waves can pass through solid as well as liquid material. The speed of these waves faster in solid medium than liquid. S waves, these are also known as secondary waves or transverse waves or distortional waves. These are low frequency but high wavelength waves. They can pass through only liquid material. Last, surface waves. These are long period waves. These are low frequency, long wavelength waves. These are transverse vibrations responsible for most of the destructions on the surface of the Earth. They confine to outer skin of the Earth. All these types are waves are earthquake waves. Initially, the primary waves are denoted by the seismic machine, then the secondary waves, and the after that surface waves we are feeling on the surface of the Earth due to the tremors of earthquake. P waves, which is known as the primary waves, which are high frequency and short wavelength waves. Because of this, they are having higher speed, but and due to that they can due to this high frequency they can pass through solid as well as liquid medium. And these S waves, secondary waves, they are having high wavelength and the low frequency. That's why they can only pass through the liquid material, not from the solid material. Okay, so the next is, this diagram is well elaborated. Here, this is we called as epicenter, the center, the point on the Earth's surface where we feel the earthquake. Okay, and from this, the earthquakes, the tremors are originating and they are passing like this. Okay, actually they are passing like in this zigzag manner, but in this diagram it is showing like a straight or the curved lines only. Okay, so here you can see these P waves can pass through this medium and this material as well, but while passing through the core they can change their direction or they can change their path. So on the basis of that, we can say there is a change in medium from this place to this place. Okay. So due to this core space, there is a shadow zone of P waves. Okay. No P waves will be reached at that point because of this core. Some waves can go refracted by this core from this place, and some waves refracted within a core and get diverted like this way. Secondly, these are the S waves which are passing through only liquid material, not from the core. This is a solid material. So here we can say the crust is made up with the solid material. In between there is a mantle which is made up by the semi-liquid material, and the core is made up with the solid material again. Okay, so due to this assumption, we can say these secondary waves cannot pass through the solid material, and this is the biggest shadow zone of secondary waves. So this diagram is very important to understand how to understand about the interior of the earth with the help of seismic waves. Okay, so now we are going to introduce with the layers of the earth. First one, crust. It is covered with the 71% by water body, that means oceans, and 29% by land. The depth of the crust may vary from place to place. At ocean bottom it is 8 km and at the land it is about 45 km. There are two layers of crust, Sial and Sima. So what is mean by Sial? It is mainly composed with silica and aluminium. That's why it is called as a Sial. Density of this layer is about 2.9 gram per centimeter cube to 3.5 gram per centimeter cube. Land part or continents are mainly made up with this layer. Sima, the second layer of the crust. It is mainly composed with silica and magnesium. Ocean floors are made up with this layer. Density of this layer is about 3.5 gram per cubic meter per centimeter cube. It is also known as a pyrosphere. Okay. Then there is one layer which is in a semi-liquid condition which is known as a asthenosphere. The material below the crust is often in a semi-liquid condition which is make the deformable layer under the pressure. So it can be make different forms under the pressure. After that, there's one discontinuity which is introduced by the scientist named Mohorovičić in 1909. It is a layer between crust and mantle. It is named after the scientist Mohorovičić. From this discontinuity, the speed of earthquake waves, that is seismic waves, is suddenly increased. Second layer of the interior of the earth is mantle. This layer lies below the crust. It extends up to 2900 km, made up with the iron and magnesium. Volcanoes and earthquakes are originates from this layer. Density of this layer varies from 3.5 gram per centimeter cube to 5.5 gram per centimeter cube. The speed of seismic waves decreases in this layer. That's why this is also known as zone of low velocity. Because of the liquid material, the speed is automatically decreasing. As you know, if the material is solid, the atoms which are there in the material, they are put together. The distance between two atoms is very less in a solid medium. But while if the medium is liquid or semi-liquid, then the distance between two atoms will be more, and that's why it will take more time to travel the waves, and that's why it is a called as a zone of low velocity. Okay. Afterwards, there is one another discontinuity which is known as the Gutenberg discontinuity. This is the layer between mantle and core, and it is named after scientist Gutenberg in 1914. He has introduced this discontinuity. The speed of seismic waves becomes slow in this layer. The last layer of the earth, interior of the earth, is core. The depth of this layer is from end of the mantle is 3500 km. This layer composed of nickel and ferrous, and therefore it is also called as Nife, mainly composed with the nickel and ferrous or the iron you can say. This layer is also known as barysphere. The density of this layer is about 5 gram per centimeter cube to 13 gram per centimeter cube. Inner core is solid state and outer core is in a semi-liquid state. The approximate temperature of the core of the earth is 3700 degrees Celsius. So here again we are having two layers of the core, inner core and outer core. Inner core is in a solid state and outer core is in a semi-liquid state, and outer core is continuously revolving around the inner core. Okay, so this is the diagram of interior of the. So here you can say this is the lithosphere about 100 kilometer here. continental crust is about 30 to 40 kilometers, oceanic crust is about 5 kilometers. Okay, so that is the width of this particular layer. You can say it is vary from 5 kilometer to 100 kilometer. This is upper mantle, and here the distance is from the outer core, boundary of outer core to the crust. The distance of mantle is 2885 kilometer. Okay, so this figure may vary from reference to reference, books to books. You can refer it. Okay, see the width of asthenosphere is about 660 kilometer. Here you can see this is the layer in orange color from the upper mantle to lower mantle. This layer is known as asthenosphere, which is a deformable layer. And now here you can say 200, 2000 and 270 kilometer is the width of outer core, and 1216 kilometer is diameter radius of the inner core. So totally you can say the total radius of the earth is about 6371 kilometer. This figure may vary. In some books you can find this figure as a 6400 kilometer as well. They are having round up this figure somehow. Okay, no one confidently says this figure is correct and that figure is wrong. Okay, so aroundly you can say more than 6000 kilometer the radius is there of interior of the earth. So here again this is well simplified diagram, you can say. See, this is the crustal part, then this is cyma, then this is asthenosphere, then again this is mantle. This much is mantle. I said 2900 kilometer is the width of mantle. 5100 kilometer is about the width of outer core and inner core. So total length here they are giving 6370 kilometers. So again the reference is changed and the figure is changed. Okay, so basically we need to understand the structure of the interior of the earth, that the first layer is crust, which is made up by two layers, Sial and Sima, silica and aluminium, silica and magnesium. After that we are having asthenosphere, which is a deformable layer under the pressure and the temperature. After that, we are having mantle, which is in a liquid or semi-liquid condition. Many volcanoes and earthquake tremors are originating from that layer. And then we are having outer core and inner core. Outer core is in semi-liquid condition and it is continuously revolving around the inner core, which is in a solid state. So the total radius is about 6400 kilometer or 6300 kilometer, whatever you can say, and the temperature is more than 3500 degrees Celsius. Okay, so thank you very much for this topic. This is the end of the first topic. We will learn in the next topic the theory of isostacy. Thank you very much.